All right, our next guest is Phillip Koskinas. He is the current director of anti-cheat at Riot Games, and his talk is going to be a comparative history of beaming pasters.
Thanks, Ryan. Good to be here. I can imagine the majority of people in the audience don't know what beaming pasters means, but it basically means banning low-effort, low-skill cheaters, which is kind of what we do at the anti-cheat department. This actually isn't confidential, but I kind of my slides always have the confidential thing in there. Some of the things I'll say we don't necessarily want every single cheater to know, so I might have Ryan cut it out later before it goes live. But yeah, if I do say something that is, if I do confide in you about the secrets of an anti-cheat, just take that to your grave. Thank you. Here's what we're going to be talking about. I'm going to talk about this as we go, so I don't really see why I would need to outline it, but we'll get into basically like where the majority of people that work on an anti-cheat come from, what an anti-cheat does, how cheaters are behaving these days with the advent of technologies like AI and the things they can do with it. And then we might even talk, if we have time, we'll talk about why cheaters can't simply become good. All right, who am I? Well, I'm Phillip Koskinas, and as Ryan kind of said, I'm the anti-cheat director at Riot, or the cheat executive officer, as I've lovingly referred to myself here. I kind of run it's kind of like a competitive integrity team. So when you think about like game studios that offer a competitive ladder, and most of Riot's games are very competitive, we kind of accept the responsibility of like protecting the time that players want to put into the game. So like you wouldn't really want to be putting in as much time. Like if you put all this investment into this game and you want to be, and you get to gold, or you put money into the game and you put stuff on it, you don't want that you don't want to see that investment you've placed in it be like devalued by encountering a cheater. And so there's a lot of ways you might be able to manipulate a ladder, and we'll get into a few of them. But that's kind of what my teams do. We make sure that that's not profitable for people that want to make a profit off of it, and then we kind of discourage the remainder of people from trying it. Here I've also put my best video game, which is a game called Super Hexagon, which the majority of you probably wouldn't have heard of, but it's a game about navigating triangles through space. And I'm really good at it, like randomly. I have no why, I can't explain it, but I've been #1 on the leaderboard for like 3 decades. My biggest fear is male pattern baldness, which you probably could have guessed. And that picture was only like 6 months ago, but I've been through a lot since then. I have like a beard now. Cool. All right, so I got my start a long time ago. I'm very old, and I guess it behooved me to say that I don't really have my degrees aren't in computer science. I actually went to school for statistics. Actuarial science is the actual degree title. So insurance premiums optimized over the probability that you might die, which is actually a really interesting science, and we could be here all day, and I could give that version of this talk, but instead we'll talk about what I actually ended up turning into a career, which was developing cheats for video games. So this is a game called Gunz, the Duel. It came out in 2005, I want to say, and then it kind of had it was developed by a South Korean studio using a very old architecture for games that was peer-to-peer. And peer-to-peer means that the topology of the game, there's no real authoritative server. What your client says to the other connected clients is what happens. So y'all might not know this, but that's like a cheater's total dream. Like it's kind of, if I don't even need to compile packets, I can just manually change things within the memory of my game executable, and other players will see it. So I could do things like my weapon fires grenade cubes, and then everybody that was connected to the game would see that. And because anti-cheat was it was in its infancy at the time, and even game studios weren't really afforded the architecture to have a central authoritative server, this was madness. It was me and one other fellow, but we basically paid for the entirety of my student career with these cheats, and this game wasn't even that popular at the time, and I think at peak we were making like $120,000 a month. It was pretty absurd. We had like 3,000 cheat subscribers. And what was interesting to me at the time, or I didn't, back then I would just sell to anybody who would buy, but what was interesting to me is most people didn't want the game-breaking features, like the things where grenades in the sky. What they wanted were things that allowed them to like appear to be good, like aimbots, things that we call aimbots today, or aim fixes, or like the ability to see through walls, which I'm doing on the left there. You can see the HP of all the people in the deathmatch. And they didn't really even care for the menu. Like I made this really cool menu and nobody cared for that. What they wanted was like the most subtle cheat of all time. And the reason they didn't care for the menu is because they wanted to stream themselves. They wanted to look as if they were the ones that were performing that way. They didn't want it to be obvious they were cheating. Unlike me, who I wanted everyone to know the minute I did it. So, you know, I finished school. We don't really have to get in too much into me, but and obviously games progressed a little bit. And this game I'm about to show here is called League of Legends. It's a MOBA made by Riot Games. Nobody plays it. It's fine. But here's me doing some of the things that I learned to do on Gunz in League of Legends. So you're not supposed to be, for those of you that haven't played it, that spell that I'm using is you're only supposed to be able to cast once every 9 seconds, but I'm doing it every millisecond. If you've also played League of Legends, you can see that I'm zoom hacking, which is, I've zoomed way out of the game. And my mom's in the audience, she'll recognize the other voice on there as a buddy of mine from back then. His name was Don. But what we had found was, and I'll explain kind of how these cheats work in a moment. You're not supposed to die that fast in this. Well, maybe if you're playing Zed, but I'll just one more moment. And those are Twisted Fate's wild cards. Again, a cooldown, a spell that's supposed to have a cooldown of 11 seconds, but that's Infinite Drain on Fiddlesticks. Very similar exploit. So yeah, what we're seeing there is even though this game is server authoritative, like as before I was saying, the games typically didn't have central authority, this one did. So what's happening instead is the servers, we still have to make requests of the server to tell the other clients what's going on in the game. And leagues, actually even back then, the game engine it was built on, if I really got into it, was ridiculous. So a lot of that authority came about from a couple of engineers that were working on the game at the time. And the way we got around it was we found that a lot of the sanitization for what the server was like clear, like not allowing to be treated as real, was done on the client side. Meaning, like if you know the spells that you could compile within the game, a lot of the enforcement for what spells you were casting were solely governed by what spells the UX would let you cast. So if you were to, you know, hook the packet handler and manually compile cast packets for spells in a character spell book, which was 1 byte, so 0 to 255, and if you iterated the whole thing, we found that eventually you would happen upon like debug spells or spells that would be instrumented by other spells within that character's spell book, and you could spam things and kind of go crazy. So when we did this and posted this and kind of got renowned for it, a member of Riot Games actually reached out to me and was like, yeah, we didn't like that, but we might like it if you came and helped us prevent other people from doing it. Which was like the first I'd been hacking games at this point for about 5 years, and it was the first time like the member of a studio had actually like, well, there was one time that somebody like sent a letter to my house, but I intercepted it before my mom saw it. But it was like trying to, you know, accuse me of, it was trying to threaten me, but they used the fake last name I had been using, so it wasn't very threatening. But this was the first time somebody had contacted me, and we helped create patches for exploits like this and a bunch of other ones that I won't bore you with. And ultimately, oh, hold on. We've kind of lost our full screen here. That wasn't my fault. Oop. Going back. Yeah, so anyway, I ended up getting kind of originally it was like a contracted role where we would just provide reverse engineering for exploits that they had seen in the wild and kind of describe how to patch them. But eventually I joined as a full member of something that was then called the risk team. And so the risk team was kind of responsible for, well, the first thing was actually trying to get a curb on bots. So a lot of what we were doing there was directly manipulating packets to the server. One of the things that immediately became a problem in League of Legends was players were making headless clients. So they were directly communicating with the server with no resources, no resource overhead to run a game client. You could even run it on a Linux server, right? Because you're just sending raw traffic. So they were using that to massively bot accounts and take advantage of the Refer a Friend program. So one of my first projects was actually removing all that stolen money, and it was about $270 million they managed to take, and we clawed it all back from all the accounts that stole it. One of my first things. But anyway, then we kind of got into actually protecting the game. And in League of Legends specifically, this is pre-Valorant launch. These are the games Riot Games makes, by the way. I don't know how popular some of them are, but Valorant and League of Legends are the PC titles for which we are kind of most focused on for the majority of this presentation. So in League of Legends, we talked about server authority. That's this thing on the far right, like game exploits. Like when you actually find something on the server that you find a way to get the server to do something that it shouldn't be able to do. Over time and by paying attention, you can actually patch out the majority of these. You can offer sanitization on the server side that makes it impossible. Like I'm spamming spells before, right? You can just make the server reject requests for that like spells in that range, and that's actually exactly what we did. We just kind of made that impossible. There's also scale botting. We talked about how you can, a lot of that is like to make sure you're running an entire client is actually really difficult, and we'd be here for a while. But one of the first things we did once we started spinning up anti-cheat resources was make it so the incoming packets to the server changed version over version. So they're like, I mean, some people call it polymorphic, but this is actually procedural. So when you talk about a network packet that's coming into a server, what the server expects changes every version of the game. And it changes in a way that's very hard to predict, which means that getting a headless client to do botting at scale is very hard. You could still bot by running the entirety of the client, but that's very resource intensive and hard to get a profit out of, because you have to run a full game on a full machine every time you want to do it. So as we started to patch out some of that stuff, a new form of cheating emerged. Kind of in 2012, 2013 was when it got really, really big, but it's called scripting. And actually, this is most cheats today are this in most games. And it just means that they're automating a certain percentage of behaviors that are normally expected to be part of determining the skill in the game. So like when we talk about aimbotting, so that's like having your mouse aim for you. You are having a program do something that a human is supposed to do. Scripting, aimbotting, it's all kind of the same thing. And when you have a server that's very authoritative over the state and there's not many exploits available, we'll talk about fog of war cheats at some point. But when most of what's available to you is just input automation or responding automatically to things that occur in game, you're sitting in this realm of scripting or aimbotting. So I'll show you what that looks like in League for the lulz. So what you're looking at here is the vein that. By the way, a lot of that stuff isn't normally rendered in the game. The circles, the exact boxes of spells, you're expected to learn those by playing it. But as you can see, this person's script, while they hold down spacebar, just calmly walks out of just immediately dodges every skill shot, and they're going to grab a pentakill here without really ever having done anything, because it automated the majority of that gameplay. So I make the joke here, scripting is a lot like, especially when you're paying a subscription for access to these repositories, which grew to be very popular. It's a lot like if your keyboard had a magstripe reader and you just paid it to play for you. And what we were talking about before is we want people to feel like the investment they put in learning to play these games, because this game is actually kind of, if y'all ever played Dota or Han when it was around, or League, or any other MOBA for this genre, this strategy genre, it takes a lot of effort to get kind of even sort of good at it. Actually, that's part of the reason it's so hard to get users is because it's so hard to get good at. And when we look at when we look at how well these scripts perform, and I'm going to share a graph real quick. I'm going to share a lot of graphs in this presentation. I'm really into graphs. especially when it's like data points on a Cartesian plane. But anyway, this is all the characters in League of Legends, and this is actually the delta between the win rate delta between the average player who is scripting and the average player who is playing manually. And the first thing you kind of grow to notice is that it's very evident. You win on average, about 15% more games cheating than you do not, even though the cheating is just automating inputs. So it's not like taking advantage of something like spamming spells or giving you an ability you don't have. It's just playing optimally human, or at the very peak of what humans would be capable of. And so that's how much of an advantage that means to a game like League of Legends. And on the right, you'll also, if you do play League of Legends, you'll recognize the majority of these heroes, these characters, are the most skill-intensive characters in the game. Callista, especially, if you've played League, requires you to click a ton and manage a lot of micro-movement. So scripting was really impactful for that. Maybe something you'll also notice is that if I'm able to tell when somebody is scripting and when they're not, then I must have, in the time that between then and 2018, we must have developed the ability to detect it, and you'd be correct. And I'll just get to I'm going to give you a little preview of the end of this whole presentation, but we did develop some of the best detection technology that the game, back then at least, that games had ever seen, solely for the ability to determine if somebody was having an application submit their inputs for them. And last year, and this is on all 4 titles, that's how many people did something like that in one of Riot's games. That figure's kind of ridiculous, by the way. Valorant on the right there, we banned 1.8 million cheaters last year. And these are not bots. These are human accounts that were trying to just trying to get an advantage in the game. And I'll get into how we got here now. So what is an anti-cheat team? What do we do here? Well, I'm going to show you what it might look like if an indie game studio spent way too much money on building one and hired the likes of me to do it. Here's kind of the mission, and I talked about it being like protecting a player's time investment in the game, but if you go one further through that, the reason it hurts to see somebody cheat is because it makes it feel worse when you lose. You're at your most risk of quitting when you lose. You don't want to lose to somebody that had something you didn't. You don't want to lose to circumstances you couldn't control. Swallowing a loss is actually how you get better, and when you can't swallow it, it's impossible to improve, and it reduces statistically even, it reduces your same monthly playtime hours because you're less likely to queue up again, especially when somebody cheats loudly. So I'll just read it out loud. Video games where you never have any doubt in the skill and dedication of a well-earned victory, even if it isn't your own. Even if it isn't your own, underlined here, because it's most important that the opponent that beats you wasn't cheating. And we kind of have done that by making cheating so prohibitively expensive as to be less accessible than cold hard practice. All right, these are the tenets of anti-cheat when we're talking about building this team, like the things that we want to take most seriously. I'm not going to read all of these to you because we only have like 30 minutes left and it would take a minute. But I will call out a few things here. One is like when it comes to developing anti-cheat tech, like tech that inherently introduces friction into the end user, even if it's just detection, it's passive, or even if it's just like an additional requirement of the player, like we need an email verification from you. All that stuff is friction, right? So we have this tenet called default to trust. You want to basically fail open when you don't know for certain that somebody's cheating, and you never want to ban somebody that you are not certain is cheating. We call that a false positive, but the ultimate goal is the reason this tenet stands there is because you can't. If I wanted to ban every cheater, I could ban everyone in the game, right? I'd definitely get them all. But we're not using nukes here. We're using we're not using landmines to hunt cheaters. We're using sniper rifles, if you want to use a gaming analogy. And the second one I'll call out is Batman, not Superman. And this one came about really quick, and some of it's because it's my personal style, but a lot of it's because, if you want players to have confidence in your ability to detect and ban cheaters, you don't have to be immaculate. You don't have to be so shiny. Like the person in my mind that is most capable of dealing with cheaters is not Superman, because he won't kill them. And I'm not saying we should kill cheaters, but I'm saying that we should, any means that is available to us to prevent somebody from cheating is something we should be willing to utilize. And that's why we say Batman, not Superman. It's also why my team is mostly ex-cheaters. We're looking for people that are capable of techniques that others might not be willing to consider. And I'm not saying like, you know, again, I won't use murder as something we should be willing to consider, but we might be willing to develop technologies like a kernel driver, or we might be willing to spend a lot of time putting honeypots throughout the game client. We might also be willing to masquerade as cheaters ourselves and like join the community as people selling a cheat, get their source code, and then use that to develop further anti-cheat tech. We may even deliberately sting cheaters by offering to sell them something and then get them to give us their information and then sue the pants off of them. Like, we're willing to do things that that maybe you wouldn't consider if you were always playing by the rules. The last one I'll call out is the bottom two that kind of focus on this war in the mind and being transparent. It's not enough to just ban every cheater, I promise you, because even though we can and we do, and we wax and wane on how many cheaters we're banning and how many people are getting away with it. But even when we're perfect, people are still getting reported for cheating, right? You suspect people of cheating even when they're not. You don't always know when somebody doesn't have PEDs. So this sort of war in the mind is, we aren't just fighting reality. We are also fighting. We also have to be visible enough that players feel like something is done, or I should say, we have to be visible enough that you don't believe anybody's getting away with it. Because if you think somebody's cheating, that's almost as bad as them having cheated. You have to kind of walk into these games walk into these queues, these ladders, with the confidence that if somebody does cheat, it's going to get dealt with. Or you might be willing to cheat yourself. And that's why we're like really, really loud about this. Like, I think I don't know, Nick could tell you, I don't know if we're loud. Are we louder than you? Riot is really loud about its anti-cheat strategies. We post stuff on TikTok. You can see me being goofy over there. When we ban people, we do it very publicly. We terminate matches. We put people in Vanguard velour tracksuits when they talk about Vanguard. We take interviews with content creators. We make it very obvious that this is a spot we're investing in. And a lot of that visibility is so you know that it's like, we can't stop all cheaters because they have to cheat before we can ban them. This isn't the pre-crime division. You're going to encounter cheaters. It's like the biggest success a game can encounter is that it's good enough that people want to cheat in it. So you're going to find cheaters. But our goal here is to make sure that, again, the war in the mind, the player knows that the cheater they just encountered isn't going to get away with it for long. And I'll also call out one other thing, and it's this ranked refund thing that every game has now. But because we know for a fact that people are going to cheat, one of the easiest ways we can provide catharsis or even ameliorate the pain of playing against a cheater is just to give you your time back, give you your rank that you lost, give you back the rating, like if you fell in the ladder, and also just tell you explicitly that, like, it doesn't, this one doesn't, but there's another notification that'll just tell you who the cheater was when you played with them, and if you reported them successfully, it'll even tell you that person we got him, thank you. All right, and so how we converted those tenets and that strategy into like a real thing was this core loop. I'm calling it the stratagem here. We've also referred to it as the four resplendent pillars of justice. But if you start to the bottom right here, you'll see it's basically about creating detections that a model then consumes to predict how much the likelihood we should trust a particular player. If we don't trust them, we restrict their machine. We place additional restrictions on them that make it harder to cheat. This is also true as you go higher in ranks, right? The higher in rank you are, the more rank you play, the more we need to trust you. So basically we do more anti-cheat the more risky or the more competitive a player is, and that's part of that default of trust. Like if you just jump in and you play casual games and you've been doing it for 10 years, Vanguard's doing nothing. Vanguard being our anti-cheat product. We're not really scrutinizing it that heavily because it would be a waste of resources, partly because it would be a waste, but mostly because like that player is in a spot where we can almost completely trust them. And all of that telemetry that we collect and all the predictions of the models kind of feed back into a very human-in-the-loop type thing. And I say human-in-the-loop because that's very pertinent in the AI age. Everybody wants to say there's a human in the loop, but there actually is one, and I'll show you why. Enhance. So this is that same thing, but kind of made a little more complicated. You know, players are coming in. We have maybe 20 different, 30 different models at any one point that are trying to predict the likelihood that they are engaged in a behavior. If we suspect them, you know, if it's perfect, if we know with great confidence that they are engaged in that behavior, then we just ban the account and ban the hardware and make it more difficult for them to get back into the game. If we know for a fact they're not, you know, fully trusted. Your trust score is at 100, just get in there, killer. And if we're not certain, we start restricting them. We start placing additional sanctions on the account, additional scrutiny on the account. We require them to enable forms of hardware-backed security. This is basically trust segmentation. This is something we call it in the security industry, but it's like we try to find our least trusted users and require the most of them. And then also, while this is all going on, to train those models that are doing that scrutiny, we're constantly taking a sample of players that are reported a lot, that have high scores, and even a random sample that have low scores to submit back to our humanized reviewing team that uses this tool we developed called InstaBan. Don't sue me. But it's basically the social media app we made for quickly reviewing. You basically swipe left if it's innocent and right if it's a cheater. And with this app, one human can review about 300 accounts a day. It's quite convenient, and it keeps our ground truth really healthy, which means we're able to learn what justice is from the actions these agents take. We don't have to. If you think about how hard it is to define explicit rules for detecting and banning cheaters, that would be very hard. But if a human has access to all the telemetry, all the in-game data, sometimes they can make a decision that's obvious to a human, but is not as obvious to an explicit rule. Like the amount of conditions you'd have to make to actually ban that person would be very difficult. But to a human who's just looking at you aimbotting, they know instantly. And then the features can kind of be exposed to the model to figure out what exact tree algorithm needs to be utilized to ban those people. So it kind of alleviates us from the responsibility of creating hard rules, and I'll talk about that too later in this presentation. The Vanguard team, to zoom out again, but to kind of make it more tangible to University of Dayton. These are the kind of people we hire I'm talking about. So again, starting at the bottom right, we're looking for like ex-cheaters, people that have made cheats for games, people that know a thing or two about the platforms we're working on. You know, it used to just be Windows, like we're trying to protect Windows from itself, but we also develop anti-cheat tech for mobile clients and for consoles. And we've even been investigating being on ARM and even looking at Linux again. If we were to make like a secured version of the kernel, it would basically be Vanguard OS, but we've considered it, right? And that's this anti-cheat engineering team. Most of them, I said before, come from ex-cheating backgrounds, but there are some that have like, you know, 3-letter agency backgrounds and have worked on client-side secured technology for things like banks and even antivirus. And then we go to the right, and we're looking at the people who make our behavioral modeling, who make our anomaly detection. And those are probably the most academic, most often PhDs in machine learning or higher level mathematics. There's also a few data engineers that are, maybe I shouldn't say the most academic, but they're probably the most experienced in how to store data of this shape. Like, so you're not just talking about storing the way they perform in the game, but you're also talking about trying to determine a picture of the operating system's risk it varies based on the operating system, what you're collecting. So it's not as simple as like a 2-dimensional table. We have very complex stores that change every month, it feels like. So that's like a full centralized effort. And then if we look at the team that's doing the reviewing, it's mostly TDAs, so technical data analysts, but a lot of people here too are also players who used to they're like ex-boosters, which are people who they're cheaters who do rank manipulation, which won't be the context of this presentation, but it's like how you people pay you to rank up their accounts. A lot of people that end up coming to us from that community are very passionate players of the game, so they have a lot of context on what competitive is, and a couple of them have ended up joining our operational team. And then finally, there's the back end. There's the integration with the games. There's the tool we talked about before, InstaBan, and that's a separate team we have called Services. And that honestly, it might sound like a small team, but it's actually our largest, because it turns out having all the API, like publishing an API for every single thing a game could possibly want from you to get like a picture of a client's risk. Developing that tool, even with Claude at our disposal, is still a lot of work, largely because all the services you might need to contact to get a picture of a player, and even knowing what state that data needs to be in, how warm it needs to be, the timeliness of the caches. Also, hosting 2 million active players at one time, all running Vanguard clients, is a very difficult problem at scale. So surprisingly, the services team is our largest by not an order of magnitude, but by almost 20%. Okay, and then when I didn't want to jump topics too quick, but we're talking about what these, like how we measure the success of this team. It isn't just enough to say like we have no cheaters, or that dumb metric I gave before where we banned 2 million people. That isn't really like telling you anything. But what we can look at is the average number of games that cheaters have to get away with, right? Or how many cheaters we call it games given to cheaters, but it's basically the number of games that any one cheater can get before they're suspended. And that's the red line, which this is a dual y-axis graph, which is another one of my favorites because it's immediately confusing to the audience, but just look how pretty it is. It's like it's Christmas. But anyway, the right side is the average games until ban, and it's graphed in red, and the left y-axis is the number of active rules in progress. And something worth calling out is that this is actually a look in 2021 and 2022. And back then, we were still our ML team was kind of in its infancy. So I was talking about like explicit ruling. The green bars are actually the number of explicit rules created against a cheat. So you can think about this as like, if this exists, then it is this cheat. If this thing happens, then it is this cheat. And it basically directly, it's a very if this, then that kind of system. It's something you directly kind of program yourself by the creation of the rule. And you can generally see that as our rule repository grows, and this is admittedly starting from like 0 for this particular rules repository, you can see that as it grows, the number of games you get go down because each cheat you try gets banned faster and faster, and it quickly drops. But you'll also see like as our rules start to come down, and this is at the end of 2022, where we started to replace a lot of our rule systems with predictive modeling. So we would instead of having to hard code a rule, a anomaly would be exposed to us, and then we would just label that anomaly as yes or no, like yes, that is a bad one, or no, that is a good one. We got even faster, and this is looking at Valorant and League totally. So the average games, and right now it's actually probably around eight games, and I'll get into that why it's come back up a little bit. But back then we got it down to as low as 4 games per cheater at one point, and it was very frustrating for them because working so hard to get around a hardware ban or something just to only be able to cheat for 4 games is not very satisfying to a cheater. And I guess the obvious question from this is like, why don't you just ban every cheater instantly? And that's because one of the core things about anti-cheat is that every time we ban somebody, we're basically telling them we detected you. It's signal to the developer of the application that there is something in the anti-cheat that is detecting them. And the faster you go with this, the closer they are to the surface to iterate against. So if you think about something like a preventative solution that sits on the front, like imagine something that's in the client that just blocks the cheat. You know about it instantly. And there actually are a couple of anti-cheaters in the audience that are very familiar with this, so I'll gesture with them. But if I put something like a block in place for a very specific driver or something, you'll just go find another one. If I don't allow that driver to load, they'll go find another method. So oftentimes we don't want to do that because we want to delay the speed at which they iterate. So we create. Sometimes you can refer to them as honeypots, but we guide them with a sort of gentle hand. We want them to go from, like methods we know we can shut down, we close down quickly, but the ones we know that there's millions and we keep it kind of open. And we try to become aware that it's happening and then give the maximum number of games we can to them before the suspension and before they've had a lot of player impact, so that we kind of control the cadence that they iterate on. Because cheaters, look, the people who buy cheats are lazy. I mean, they're not trying to get good, they're trying to cheat. And what is the saying? You either are good, get good, or cheat. Well, they kind of ruled out the first two, and they're focused mostly on the last one. So they're going to do the bare minimum to cheat. You can almost be assured of that. And to make sure that they stay as dumb as possible, we kind of try to keep them lazy. And I also talked about like that we want to give them maximum number of games that we can. One of the ways we do that is by using not just the rank that cheater's at, but how hard they're cheating. So like if you think about aimbotting in Counter-Strike or in Valorant, if they have a really humanized aimbot, like their advantage is small, like statistically they're not getting that many more headshots, it's very undertuned, but we know they're doing it, we're going to let them get away with it a little longer because they're cheating softly. And once they start to crank it up, we're going to ban them faster. And the amusing part about this detection in stages is that it trains them to cheat quiet. So it keeps, and when we're talking about war in the mind, even though they are cheating, they've learned to not be loud about it, not to rage hack is what we call it. And that means that these big cheating, spectacles that can sometimes plague other games or can sometimes especially plague first-person shooters don't show up because cheaters aren't cheating that loudly anymore. They don't like just crank it to a 10 and start raging. All right, and finally, I'll talk about this is anti-cheat in 2026 to kind of bring it home. This is the percentage of matches that are infected, and in each of the titles that we've been talking about, LoL, Val, and I won't talk about Wild Rift so much, but that's a mobile title it's League for mobile. But the one thing, in 2024, League of Legends, which was using a legacy anti-cheat system, not Vanguard, not the one we had developed with this team I've been going over, finally made the decision to switch to it. And at the time, just before they switched, they had very limited detection capacity, but once they had switched and we had Vanguard and could see the number of people that were scripting, we immediately were able to calculate the match infection rate because all the games those players had played were considered tainted. Now, when it was put on the game, it was 4%. Within days, it had fallen to 1%. And some of that's because we outright banned them, but a lot of it is because they just stopped. Because there's a lot of preventative solutions within Vanguard that make it difficult to cheat, sure. But once the stakes were that high and like hardware's at risk and the accounts they had been cheating on for so long were at risk, they just quit cheating. And so that, like, one of the advantages of having the brand of Vanguard that can just kind of like give that kind of confidence to a game is that a lot of the developers that had their hooks into the the League scripting population and were offering monthly subscriptions just vanished because they no longer really the level of update they'd have to make was too much. They didn't want to deal with. They weren't raised in the Vanguard ecosystem. A lot of the cheats they were making required deep hooks into the game client that were no longer viable with the methods they had been using, and they just left. They took their money and went home. So it very quickly dropped. And actually, even today, League is probably our least cheat-infected game, largely because the amount of information you need out of the game client to do it requires that you kind of open yourselves up to a lot of detection methodology, but it's also because the difficulty doesn't, like, we're talking about a 22% win rate from perfect scripting, and like if you perfectly do it, it's not worth the means, right? Automating in that game is not, if you aimbot in a game like Valorant, you were probably you could instantly win. You could just put that thing on autopilot and you just win the match. But in League, you can really only get to like 22%. And then the second thing I'll call out is like pixel bots, which are when we're talking about automating cheats. It's a cheat that sits totally outside of the game, or totally outside of the. It can actually even exist totally off the host that's running the game client. But it's basically a cheat that just reads the screen. And because I'll get into this just in a moment, I'm glossing over it a little bit. But when Vanguard gets very strong, when it's at its strongest, one of the ways we get attacked, we start seeing ourselves being attacked, is with something that's called like external pixel botting. So let's get into that. Where are cheaters going next? Well, they just gave a spoiler. But I'll tell you, it's not the McDonald's careers page, which is probably would be a better use of their time. I'm going to use these colors the whole time, so I'm going to stick with this color system for the remaining slides. So when we talk about cheat classes in a game like Valorant, which is a first-person shooter, they kind of fall into three categories. One is pixel bots, which is they basically just read the screen, do color sampling. They're not actually some people have tried more ML-driven approaches, but for the most part, they're just color sampling the screen, trying to identify where an opponent outline is, and then issuing a mouse update to point your in-game direction towards that player's head so you get an instant headshot. The second way that is wildly popular but is difficult to keep up with because it's like the most expensive form of cheating is something called DMA. It stands for direct memory access, and it requires specialized hardware to basically introspect a game client over the PCIe slot. So you're basically able to get pages of memory, securely exfiltrate them to a second PC, and because we won't get super into this, I'm going to stay high level, but it's basically a way to cheat undetected without you can get reads on where opponents might be on a second machine without really triggering the anti-cheat on the main one. And finally, there's internal cheating. And I was actually having this debate with Ryan and Nick earlier, but it's like, what do we call an internal versus an external cheat these days? And it has kind of changed over time. But when I say internal, I'm referring to a cheat that occurs on the host. So it's usually something that is either loaded a library into the game, like the cheats you saw me doing at the very beginning of the presentation, or they're corrupting Windows itself to masquerade as the operating system and do their cheating that way. Now, I love graphs, so let's look at some that kind of highlight the frequency and severity of those cheats we just discussed. Now, this is the matches infected by vector, and it's a stacked area graph, so it's very difficult for you to compare, and you're probably like, what am I supposed to do with this? I can't use it. So I normalized it for you, because I'm a good data analyst, and I want y'all to be able to make comparisons with your eyes. But using the same color system we used before, you can see over time what percentage of cheaters are using what method. And one of the things you can see that started happening, especially later last year, is that some of the forms of internal cheating, the yellow, the very bright yellow, have started to kind of wane in popularity. And a lot of that's because when you're cheating on the host, you're exposing yourself to the anti-cheat system. So cheaters have started to, and it's actually even worse. If this kept going, you'd see there's even more external pixel botting now. Although DMA is probably the red is probably less popular if you were to extrapolate closer to today. But the green has grown, I guess, has exploded. About 50 to 60% of our cheats right now are pixel bots. And that means that, well, one, it tells us that our anti-cheat system is kind of effective. But it also tells us that cheaters are more, like, despite the effectiveness of that, cheaters aren't going to give up. Like, the advantage of a pixel bot is there. It's because, like, as you can see here, it isn't actually changing the raw number of cheaters. It's just where they're coming at us from has changed. I'll talk about a pixel bot now. Okay, I've given a basic diagram of how a pixel bot functions on Valorant over here, and you can see I've kind of just pointed out that it's basically just Python reading the screen locally. But unique to Valorant, and because of the Vanguard anti-cheat system, you need an external microcontroller to interpolate. You can only have one stream of direct input to the game client. So they need an external microcontroller to interpolate the updates from the trigger bot and the updates from the mouse into one stream for the Valorant client. And because it necessitates that microcontroller, we have a small barrier to entry for pixel bots on the game. And when we talk about getting, like, if sorry. I wanted to show you all what it looked like before I get into the next section. But this is what a pixel bot looks. Okay, well, obviously we banned them, but that's what a pixel bot looks like. You can see that it just snaps immediately to the head and fires. Actually, most amusingly, it intercepts the trigger event, and right when you go to click, it just updates your aim so that you're on a head. And it makes it one of the convenient things of making the user click is that it feels like it's them. So one of the reasons they're so popular is that you feel like you're a god when you use it, because you're like, haha, I'm the best, I can't miss. Very great marketing strategy. But one of the difficulties with doing it this way is actually that you are still reading the screen locally. And we talked about doing stuff locally and what that means for an anti-cheat system, but it means we have, Riot and Vanguard have the ability to know that the pixels of Valorant are being read. And sure, that could be because you're streaming. It could be because you sent a screenshot to your friends. You could be on Discord. Any number of reasons you could be streaming for. But eventually, there are methods to scrutinize that and determine that it's occurring with some anomalies in the mouse behavior, right? So how do we get even the screen reading off the host? Well, I'll show you, because actually this kid's doing it. You can see there's there's an HDMI output here that is feeding the input into a second PC, or is it this one, Ryan? Well, in any case, we basically got a cheat running right here. We are sending the screen data from one computer to another computer. And what that means is that if Vanguard was running on this guy, my guy, it wouldn't have the ability to really know we can't scrutinize what's happening off of that host. So they do this in one of three ways, and honestly, probably the most effective is the former. But it's just stream it off with a library like OBS. Just use like a streaming library that's normally used for streaming gameplay, and have a library in there that streams it to a second, or creates, maybe even opens an endpoint for a second PC to connect to, but you're basically just getting the screen data to a second PC with the lowest latency possible. And then that second PC runs the same thing your original PC was running, to the color scrutiny, to make the mouse updates to your Arduino or your KM box or whatever your microcontroller is. And then the same thing occurs. You're just updating your inputs. You're updating your input invisibly on the host. And this form of cheating probably sounds insane to y'all, and that's because two PCs is probably more friends than you'd have if you found yourself trying this. And also, I didn't mention before, but you have to solder actually, if you're using a simple Arduino, you still need an extra way, because they only come with two buses. You actually have to solder an extra piece onto your microcontroller so you can actually get the input from the second PC. All right. How do we fight that? How do we fight that's what's completely off the host? Well, we actually do. I talked about having some ways to force one direct input stream. That's definitely the first. There's arguments that one of the self-defeating arguments of anti-cheat is that, like, why would I do all this work to make them require direct input, or why would I? If there's a way around something, why do it? And that'll defeat you as an anti-cheat team, because to give you an analogy in the real world, like, locks are defeatable, right? Like, you can pick a lock, you can actually break a window, but you still have locks in your doors. And the reason for that is because you're adding one extra tool that a burglar needs. You're making them carry a set of lock picks, or you're making them risk triggering an alarm for breaking a window. But in any case, it's just because security can be defeated doesn't mean it's pointless. So one of the advantages we get from requiring them to do direct input is that they need that microcontroller. And actually, perfect USB pass-through for a microcontroller is very difficult. So a lot of the ways Windows might query a connected USB device, you'll notice that when you query an Arduino that's trying to do pass-through calls to the mouse, unless they perfectly emulated the way that particular hardware manufacturer mouse responds to all those calls, it creates a detection surface. And that's actually a lot of surface, because it's very difficult to get every single thing to respond perfectly for every one of your customers when you sell a Pixelbot. So tons of detection surface there. But eventually, those things can be solved. You can get completely off the host. You can get perfect USB pass-through over a lot of time. And then you are technically cheating undetected. The only thing that remains for us to scrutinize is your aim in game and the input to the game client. And so that's what we do. We scrutinize it. And it's actually, to this day, even though we have all this AI at our disposal and every aimbot is trying to humanize itself, it is still, with varying degrees of efficacy based on how hard you're cheating, it is easy to know when, for even a two-dimensional array that's just mouse coordinates, like just a simple, we've actually even done mouse classifiers that are just aggregates of like angular velocities. This gets into the ML stuff, which is not the topic of my talk, but like a uniform time series approach will work. And I've kind of put over here the y, like it's just the up and down of the mouse over the sampling time, and you can see that when the aimbot takes over, it's suddenly a line, like human line, human line, right? And a lot of those things are also accompanied by click events, because that's what you need to do to click on an enemy head. So you don't even need to scrutinize the entire window. You only need to scrutinize when the weapon is fired, which reduces the amount of data you need to collect, and also the amount of stuff you need to process. But when you're talking about doing the ML on the input, we're looking at about a a 60 to 80% recall rate for people that are even with humanization today, and recall refers to what percentage of cheaters we are catching with this in our lab. But even the ones we don't catch, even the ones that like the ones that are the ones that we're not catching are so humanized that the advantage is almost negligible. They can only cheat within the bounds of what is technically human. Like we've drawn a very clear line of like, our algorithm learned. I shouldn't say algorithm. Our machine model learned pretty much exactly what humans are capable of, and then cheaters solved for the edge of that surface, right? And that means that they are no longer able to perform superhuman, only like at peak human capability. And they're honestly not there yet. I'll be frank. It's going to be a couple more years before it's like totally line on line. But once we have them in there and they're kind of performing at the per shot event, each shot is human, then we still have the ability to look over a longer period of time, because even somebody like Usain Bolt ran slower some days, right? So it lowers our time to detection when you cheat quieter, same as we see today, but by banning anybody that performs totally superhuman, we slowly kind of bring down the quality of cheating. Oh, and I'm going to do one more graph. Actually, I might do two more graphs. I don't know. I like graphs. But what we're looking at here is the reason I talked about before why they're prioritizing these types of cheats. When we look at internal cheats here rendered in yellow. These are box plots, by the way. I'll explain what this graph is, because I don't think everybody in here is a statistics major. That's probably just me. Any? Show of hands. Statistics. Losers. All right. Anyway. So it's basically 50% of the data falls within the box. The bottom of the box is the 25th percentile, top of the box is 75th percentile. If I was any sort of good statistician, I would probably put the median with a white line in the box, but this is a Google chart and it doesn't support that, so it's not my fault. But you can see that basically, if you're cheating internally, most of them are getting banned so fast it's almost not worth it. And so if you're a cheat buyer, if you're a cheat subscriber, you're going to gravitate towards things that let you cheat for longer. And so here you can see the external pixel bot is probably the longest, and the second longest is DMA. So that's why those methods become popular, because it takes us the longest to be certain you're using them. Now, if we had time, I would go over DMA architecture, but we don't, and really only Nick would care, so we're going to skip it. So my last section is going to be, why do cheaters get good, or why do cheaters refuse to get good? And there's a lot of takes on this about why they do it. But the first is just because it's worth it. If you got if cheaters are attacking a game, it means the game is good enough to warrant it. Now, I'm not talking about people that just cheat loudly, shoot a bunch of grenades, because sometimes that's just something we do for attention. But if you're cheating quietly and you're doing it for a long time, it's because that border or that trophy or that icon or whatever you get at the end of a competitive season is worth it. So first, if you're a game developer, you can interpret that as a compliment. Thank you for cheating in my game. That means so much that it means that much to you. But there are obviously a lot of other motivations, and there's people that have tried, and I'll give an example. We've tried to kind of understand and size the motivations and the reasons people do it, and you see the largest is just people buy cheats and they do it for glory. And we also have the developers that get their hooks in on the money segment, and they do it because it's how they're affording their car payment. And certainly we have even researchers at the top right who do it to get their name in the paper, to get the CVE, to be the guy that broke the game and have everybody know it was you. But I'll simplify all of this for you really quick about who cheaters are. They're just teenagers. Look, they don't. A lot of people think their enemy is sophisticated and has all these advanced motivations, but 99.9% of cheaters are doing it because either their friends did it or doing it because games are it's what their culture is involved in, and they haven't quite developed the empathy to know that it's wrong. They can't get any better by skill alone. Maybe they don't have, the only thing they've got at their disposal is mom's Amex, so they subscribe to a cheat. They get a little addicted to it. It's how they end up playing the game. They're not interested in playing fairly yet, so the thing they're going to do is cheat. And it's important to note that even if we stop them from cheating in our game, they would probably go cheat in another game. And I'll kind of talk about this now, but it's banning a cheater doesn't really reform them. Like we talk about doing bans and the big ban figure at the beginning, but a cheater's going to keep cheating even if they have to find a new game to do it in. And because the way they engage with the game now, for the time being, is by cheating. You need an extremely, we've measured this statistically using like Vanguard's hardware IDs to determine what the reoffense rate is what we call it. And it's absurdly high. Like 99% of cheaters reoffend, even if they've been banned 5, 6, 7, 10, 25 times in a year, they are still cheating. What we found though is that like an extremely long break, like the time it takes to go through puberty, will make them stop cheating. So how do we help cheaters help themselves? Well, I have one theory. I'll share it with you. And I'll share it with you now. This is something we send to cheaters when they're using a particular type of cheat or they're super invested. We basically fake a BSOD on their screen using the Vanguard software. And it's mostly just goofy. It's kind of like a prank we play on them. But the thing we're trying to do is make it not cool to cheat. Like this, it's like, one is we're gonna get you, and two is like you don't have half the sophistication we have, and it might seem like it's chest thumpy, but it's really like exposing them to the other side of this equation. Like, hey, when you're done with all of that, why don't you think about anti-cheat? And it's meant to. Like if you're a cheater and you're faced with that in your mom's basement and you're surrounded by like darkness and just the red glow of your monitor, you're like, man, and you're like sitting alone and that's the only illumination you have. I kind of hope you're alone with your thoughts long enough to think about a different way to approach gaming. And that's my talk. That's the whole thing. And again, every time I play a video, Ryan, every time. But yeah, I can open it up for questions now. Thanks for listening.
So we'll take a couple questions now. We do have an anti-cheat panel after this that's going to be open to questions for everybody for longer. So we'll do maybe like a couple questions now. So raise your hand if you have any questions for Phillip.
So I'm curious, in games like League or Valorant, what % of player cheater reports are actually cheaters?
You've probably read something I've written that says exactly that. Not very, it turns out, but it does vary with rank. So the higher ranked you are, the more accurate your reports become, because probably not just because of your time spent playing the game, but also because the number of cheaters that get to that rank are small. So if you encounter them and you're reporting them, you're usually simultaneously aware, and it's very it's usually like somebody that has been cheating that long is getting a lot of reports because they've survived a long time, so they get kind of a reputation for cheating, and they're eating reports from people who normally wouldn't be reporting. But the one thing that's very amusing about this, and I think you asked this question for this reason, is that the most accurate reports for cheaters actually come from cheaters themselves. What I mean is, when we look at the buckets that report most accurately, people who are cheating at the time of their report are the most accurate reporters of cheating. And that's probably because they know what cheating looks like. But if you think about it, it's also kind of, at least to me, it's amusing to be like, hey, that guy's cheating. And it's like, how dare he cheat in the game I'm cheating in? And that kind of brings me back to my teenagers thing where it's like, it's like a lack of self-awareness that kind of creates this thing. It's like, I'm allowed to do it, but how dare he? Anyway. You asked for a raw percentage too, so I'll tell you. It's about less than 1% of total cheat reports are accurate. It's pretty abysmal. It's slightly higher on Valorant because in League you're just reporting something that happened in the game top down that you saw. In Valorant there's a spectator camera, so when you're done, you kind of continue observing the game from your teammates' perspectives, and if one of those teammates is cheating, you actually have kind of immediate insight into the fact, like their point of view, that they were.
Other questions?
Okay, so for someone of your background, you're not like what people traditionally expect. So I want to
My mom's in front of you. Be careful. No, I'm kidding. No, so yeah, go to your question, sorry.
So basically, I'm not asking step by step how to cheat. That's not what I'm asking.
No.
I'm asking,
sure, because I wouldn't tell you.
I'm asking like, how did someone like who isn't really like expected to have the anti-cheat skills that you have in your position, how did you go from like,
I cheated. Like we talked about who cheats, and I was just.
was it like a
I was this once. So I was in my mom's attic, actually, as you'll recall, and I had a lot of time on my hands and no girlfriend. So and that actually, if you're thinking about how we may ameliorate or remediate people cheating, maybe we just buy them girlfriend. Well, we shouldn't say buy, but we create an app to hook them up with, like, hook cheaters up. Anyway, point is I was alone in my attic, and I bumped into a friend who was doing some disassembly of a game, and I saw him cheat, and I was like, why not me? And I don't really, when it comes to programming, because a lot of those skills are required to do this stuff, I had already been exposed to C++ through school, so I already knew enough about, like, compiling a binary, and and the Windows APIs he linked me to use to do the library, to do load library A, which was the way he used to cheat back then, were actually quite trivial. And he ended up becoming this person became a resource for me to teach me some stuff, and then, it was kind of that friendship that kept us, like, cheating in new games. We would find new games to cheat in. I would try, you'd play legitimately at first, but then you'd eventually crack open the game client in IDA or something and start looking around. And I think your question was, like, that background, like, I did not think that would go anywhere. I was doing it, when you're young, not everything is meant to have a purpose. I was doing it, I was not thinking more than a day ahead, really. You're not capable of doing it. It was just something I enjoyed doing. Also, that's like, if you're like, how to get into anti-cheat, like, one of the best ways is to start cheating. And it's like, but that's, how do you do that in a space, especially once you're kind of like, you're not trying to get yourself banned, because you'll become part of a deny list these days. But, like, we don't outright, because we're involved in the cheating communities that are doing the analysis. We talked about Batman, not Superman. A lot of our sourcing comes from interfacing with people that impress us in what they're able to determine about the software we make. So that's actually how I got into it. Was like, I know how your game works. I was way more egotistical about it as a child, but it was like, I know exactly how this thing functions. Watch me break it. And it's very similar how we do our sourcing now. It's like, you show us the exploit you made, and then, like, we'll make it harder for you, and over time, they end up becoming a member of the team, and that's kind of probably the strangest recruiting mechanism I've ever heard of, but it is one that works for us. Like, in terms of, for, like, how to cheat, or like
figuring out the technology?
No, so that's what's amusing, is there's forums that aggregate a lot of the analysis of specific game clients and the techniques we use to do the analysis. But if you're talking about way back then, it was so undocumented. Like, the niche was so niche. It was very hard to find. Actually, that was part of the allure, was that it wasn't written down for you, and you had to really find it yourself. And some of the ways, this is so fun. Actually, I didn't get good at RE from looking at game clients and, like, just raw machine code. I got good by looking at other people's cheats. Like, so I wanted to know how the cheat functioned, and through that, I found the game functions they were referencing. And by understanding the cheat, then I knew how to reference. They did the analysis for me, if you think about it, because they had already had a working cheat. And then I would, from there, kind of understand the game's internals and be able to instrument the game functions myself. Yeah, that was a really good question. Thank you.
Other questions?
Teenager slide up here forever.
I'm seeing a lot of, like, hardware-based cheats appear in recent years. So I was wondering, what would the approach be for, like, I'm seeing something like the MSI, like, gaming monitors that block flashes that I'm seeing all over the internet right now.
Yeah, so I talked to MSI, and they're not releasing that. But I'm glad you asked this question. So we're talking about off-device cheating, and this is a DMA graph, but I'll focus on monitors and peripherals that could have, like, an NPU, like, they'd be able to do something like determine a flash is present and dial down the brightness. So there isn't a way to completely prevent that. Just frankly, game design is going to have to adapt to the existence of this stuff. Like, we're going to have to, bangs won't be, like, we won't be able to do we'll have to cull objects from the client completely from a game design perspective, or, like, do full blindness. We won't be able to send you some data anymore. Like, the way we do information control in games has to change. Valorant, admittedly, most of the things are full occlusion. Like the smokes are total smokes. Like you don't get a little bit. You either have visibility of the opponent or you don't, which is good because it means stuff like that can't become an advantage. But other games are going to have to start to do this. Also, you could imagine if you extrapolate, like having that NPU on the monitor could mean they could also just have a USB bus there that does exactly what we're talking about when we talk about pixel butts. It could just become that second PC could just live in your monitor. And it could just do the aim updates for you. So we're not, look, it already exists. We're not trying, this is what that is, right? We're not, but we don't want the barrier to entry to be go to Best Buy and buy a damn monitor. So like one of the best defenses, and we're talking about putting locks on the doors, is I have partners at all these hardware companies. And I'm like, you knew I was gonna be here when you did that. And so like, and we work with NVIDIA, we work with Nick. Nick is also a member of the anti-cheat team. We have internal groups that we use to put pressure on vendors because it's like, you like money, right? Like you're trying to sell this to make money. What happens if the gaming monitor defeats gaming? We have the same customer, dude. Like we want gaming to last. And so if we want it to last, then we have to protect it. And they actually completely see reason on this, and all they want to know is that we're enforcing that line with all the other manufacturers. So like, then I want to see that same scrutiny you're paying me paid to everyone. It's like, I guarantee you I will. And so we can make it less accessible, but we can't stop it. The only thing we can do is adapt, like in terms of like what a competitive game is. And so that's where we're focused on a lot of it. I'll say a game like League of Legends 2 is so visually, like, just like, it's so, like, the monitor can't give you that much of an advantage. It's very difficult to sort. A lot of the best neural net for reading a League screen is the one in here right now. There's actually cheats that have tried to do complete external, like just screen reading on League, and they just suck because there's so much stuff in that game, and it's like very hard to train something to digest. Even object detection, which works, you won't know what spell's being cast because it looks a million different ways on a million different skins with a million different chromas, and it's like, nobody wants to put in the effort. It might be possible, but it hasn't happened.
Is that a similar thought process to like the new Super Strike and new click technology that's going on?
You might have to educate me. Super Strike?
Yeah, the new Logitech mouse that is.
Yeah, what's the feature we're most concerned with?
Well, it reduces input latency on average by like 30 milliseconds if you use it right.
I mean, that doesn't bother us. Like peripherals can innovate in the space of ease to use. Like you can make them easier to use in the sense that if it makes, like how soon your click actuates is not really something, like yes, that should be an advantage, and it is something you should, like, if you're truly serious about gaming, I'm personally okay with the idea that you should find the mouse that works best for your play style, and that one works better if you're like a run and gun type person, or you want to be able to, like, also emergent gameplay sometimes shows up that makes the, like, lower actuation better, and like then there's people who are like high sensitivity, low sensitivity. I see that in the same vein as like pick the thing that works for you. We just don't want the mouse taking actions on your behalf, and that's where Wooting kind of pushed the line, right? Because it's straight in the other direction when you let go of one, and that's like one less key press for you. Actually, it means you just don't have to use both fingers, but yeah.
All right, let's go one more question, and then we'll break for lunch.
No, she doesn't get
We'll do two. Your mom can ask a question too. Maybe last.
You mentioned your major was in like actuary sciences.
Yeah.
That's data risk analysis and stuff. Do you think that is used in your job today, or do you think like maybe you didn't need any, like, I don't know, could you have changed for like computer science or anything else and still kind of ended up where you are?
I do use it. Obviously not the insurance components, and not even the second order derivative components. I use probability a lot. So a lot of ML and a lot of the behavioral analysis we're doing, especially when we talk about aggregating over matches, kind of ends up taking a form, like it ends up being binomial in nature, and we're really like the approach to knowing if somebody is truly anomalous is just how many times they're able to do it before they fail. And so I guess that's kind of like a very math prob type shaped question, but no, I don't really use it that often. The statistics components we do use because I do a lot of hypothesis testing in my day-to-day, but that's not for cheaters, that's to get money. So it's like to prove that we have to demonstrate that the investment's worth it sometimes, because this is a lot of money we're spending, and if We have to demonstrate that it actually has an impact for our customer, that it matters to our customer. So we have to do a lot of A/B testing on like how much cheats actually impact the user experience per genre. And so the hypothesis testing shows up a little bit. That's more stats than actuarial science. I haven't used LifeCon since then. I guess when I went to buy a house, I used the future value of money pretty heavily, but that wasn't in my job, so.
All right, take us home, Ms. Koskinas.
Okay, so I learned today that there are loud cheaters and quiet cheaters.
I'm the loud one.
I would like to know, when you were up in my attic, it
Wasn't a
sounded
basement.
really loud.
Yes.
Were you the loud cheater?
I was the loudest cheater, Mom. For me, it was the spectacle of cheating. When we talk about like why people cheat, and I didn't like nobody knows this at the time. You don't know who you are when you're a teenager. But like when you look at like people who do it for attention, like that was me. Like I was like a rager. I was just doing it so that I'd have control of something and people would see me doing it. And I didn't actually and then you slowly progress through the life cycle, so then I become a developer. And once the money started happening, I wasn't really cheating loudly anymore. For me, it was like I was providing something for a customer, and I kind of matured emotionally and was like, I want to make a good product. And I got, like we were talking about before, I got rid of those features because those broke the game. And similar to the monitors, I was like, our customer's the same person. We don't want to totally break it, right? And that game I gave an example of before, actually, Don broke it. He broke the rules because he eventually managed to simulate traffic from another client, which meant he could spoof himself as another person. He could spoof requests from their client. And I asked him not to. I was like, please don't, because this is money that we need. But he deleted the entirety, like everyone's characters. He spoofed a request to delete characters for everyone on the entirety of the game. All 20 million characters deleted. And we found out that their backups were monthly. So it was the slow death of the game. And I told him not to do it, but this man cannot be reasoned with. He is without logic. Anyway,
Let's get a round of applause for Phillip.